Thank you for joining me on this question in exercise 2b. I'm going to be looking at question 1c. This is for each quadratic function. Determine the equation of the axis of symmetry, the vertex, its concavity, domain and range. So the equation is y equals 3x squared minus 12x minus 5. And question 1a and 1b, if you've seen it, I used completing the square for 1a and I used graphing for 1b. So I'm going to use graphing again to answer this question. So from the graph, I will answer the questions. So let's find first of all, I'll find the turning point, and that happens when x equals negative b over 2a. So the turning point, a equals, the a value is 3, the b value is negative 12, the c value is negative 5, and so it'll happen when x equals negative b, so that's positive 12, over 2 times a, so 12 over 6 is 2, so it happens when x is 2, and if we substitute that into the equation to get the y value, we get 3 times 2 squared minus 12 times 2 minus 5, so we get 3 times 4 minus 24 minus 5, so negative 19. 29, negative, is that right? No, negative 12, 12, negative 12, negative 17. Okay, let's do the mental maths. Negative 17. So that's where it's turning. It's turning at the point 2, negative 17. Now let's find the y-intercept, and that happens when x equals 0. It crosses the y-axis at the constant on the end, or you can substitute 0, y equals 0 minus 0 minus 5, negative 5. So it's crossing the y-axis at 0, negative 5, and its x-intercepts, where does it cross the x-intercept? And that happens when y equals 0. So we substitute 0 in for y. 0 equals 3x squared minus 12x minus 5. Now you can use quadratic formula or factorize. Will it factorize? B squared minus 4ac is 144 plus 60. So that is 84. 144 plus 60, 204. All right, well, look, maybe my mental arithmetic's not great. I'm just going to use quadratic formula. So that is positive 12 instead of negative 12, plus or minus. B squared, 144, minus 4 times 3 times negative 5, all over 2a, which is 2 times 3. So we've got 12 plus and minus. 12, 60, yeah, that's 204 over 6. All right, now to do the graph, I don't have a calculator because it's a non-calculator. Now, square root of 204 is somewhere between, square root of 196 is like 16. And so we're just a little bit bigger than 16. So we're dealing with numbers like 12 plus 16, which is 28, over 6. So we're dealing with about almost 5. So approximately, that's 4.8. And 12 minus about 16 is negative 4. Negative 4 over 6, about negative 2/3. Negative 0.66, negative 0.7. So this is just approximately, right? Notice I've got approximately. Let's sketch this. So we've got a y-axis and the x-axis is at let's put the x-axis here and let's put it at let's go 2, 4, 0, -2, and let's, because we've got to go down to 17, let's go up 5, down 10, down 15, down 17. So let's put our points. 2, -17. I was thinking that's 20. 2, -17 is about here. 2, -17. It crosses the y-axis at -5, that's here. And it crosses the x-axis approximately, and I'll use red points here, at 4.8, approximately here, and -2/3 approximately here. That's roughly, okay? Now if we join these points here, that's not very smooth, let's try again. That's good enough. Right, so there's our parabola, although it's still not the greatest parabola. I'm going to do this again. Yeah, that's a little bit better. Why not? Give it a try. The third time lucky. All right. So let's look at our questions. We wanted to find the axis of symmetry, and that happens at this line here, the x equals 2 line. So the axis of symmetry is the x equals 2 line. The vertex is at the turning point, which is 2, -17. It's concave up, you can see, because it's got an a value of 3, since a is 3, and its domain is all real numbers, and its range is, and I'll just close that. Its range, I'll put down here, all y values above and equal to -17. That answers the question. We didn't have to graph it. Keep in mind, we didn't have to graph it. All we needed to do is we could have stopped. We could have stopped here. Once we knew the turning point. Once we knew that turning point, we could have said, okay, its axis of symmetry is through the x value. So we could have answered part 1 straight away back at this point here, and said that's the x equals 2 line. And part 2, we already had the answer at that point, was 2, -17. And for concavity, we see that it's concave up, since the a value is positive 3. And we already knew that the domain was a set of all real numbers, and we knew that the range was all values greater than or equal to -17. So this wasn't really necessary. This wasn't really necessary, but this part was necessary. And so it's really just for clarity. By drawing a graph, it helps. But in an exam, manage your time and only do what's necessary. Don't do, it's okay to do all of this, when you're learning, but to answer a question on an exam, this shouldn't have been necessary, this shouldn't have been necessary. But this one, part turning point, definitely was necessary. So I hope this has helped. Until next time, stay happy.